Hi there everyone, it's time to talk about air pollution. And what do you do when the air is dirty? And it's a simple question, but an important one. The air, in many ways, is the part of the biosphere that we interact with most immediately. We obviously need water very regularly, but we breathe air all the time. So if there's things in it that will harm us, we can't really avoid them, and that's a problem. So what is air pollution? It's quite self-explanatory, but we can always use a definition. Air pollution is when substances get into the air, either as dust or gas or vapor, that are harmful to humans or animals. Here are some different examples of air pollution, all different types of fire-based air pollution. However, there are obviously other types. There is some natural air pollution. The volcano seen on the right is one example of that. But since the Industrial Revolution, humans have been producing more and more air pollution of their own. So we find air pollutants in three different forms usually. Solid particles, which are small particles of soot or grit or pollen that float around in the air because they are so small. The same can happen to liquid droplets, tiny little drops of liquid that are small enough to float around. And of course there are also gases which can get into the air. And in the picture you can see dry ice, carbon dioxide sublimating. It moves like a gas, but really that picture is a bit of a lie. That is a vapor because you can see it. A real gas is made of only molecules of a substance, and a molecule is invisible to the human eye. So all gases are invisible. So we need to distinguish between primary and secondary pollutants. Air pollutants can be one of those types, primary or secondary. Primary pollutants come directly from a process, i.e. ash from this fire, or the carbon monoxide from a car exhaust. Secondary pollutants are, on the other hand, formed in the air when primary pollutants or other gases in the atmosphere react with each other. So here we have, say, a primary pollutant in one case, and if it interacts with sunlight in the atmosphere, we can get from it secondary pollutants, or maybe another harmless gas and a secondary pollutant. So this reaction that takes place motivated by sunlight is called a photolytic reaction, and photolytic reactions happen a lot in the atmosphere, as you can imagine. There are also regular chemical reactions that might happen up there. So particulates, it's derived from the word particle, and that's exactly what it is. A particulate is a tiny particle of solid that floats around in the air, and they're small enough to be breathed in as a gas, or in the same way as a gas. They can be natural, like pollen from plants, or dust, such as in this dust storm here, or they can be anthropogenic, like the ash from burning fires or fossil fuels. Breathing in particulates can damage your lungs or cause other health problems, especially when those particulates could be radioactive, say, or some other health hazard. Another word or gas you will no doubt have heard of is ozone. It's a molecule of oxygen. So oxygen is an element. It has the symbol O. That is an oxygen atom. And here's an oxygen atom wandering around on its own. So we start off with the single unit of oxygen, an oxygen atom, but in a gas, oxygen atoms usually join together in pairs to form oxygen molecules, which we call O2. No doubt you've heard of that. So the energy of sunlight can break molecules apart, and sometimes another oxygen atom comes along at the same time. And under those circumstances, you can find that the oxygen can be formed into a special molecule with 3 oxygen atoms, and this is what we call a molecule of ozone. Of course, ozone can be made in a number of ways, but this is one of them. So tropospheric ozone is an important natural gas, and many processes in the troposphere need it, but at high levels, it is a pollutant that causes smog. This is a photochemical smog where ozone reacts with air pollutants in a photolytic reaction to create this haze lying over the city. At very high levels, ozone is toxic. Over time, it slowly destroys organic substances. Ozone did this to a rubber tire. Some plants show leaf spots and discolorations that are caused by low-level ozone. Imagine what lots of ozone in the air does to your lungs. So, ground-level ozone is formed in a complex series of chemical reactions. We're not going to go through those reactions in full detail, but it's a good idea to run through them as an example of how secondary pollutants are formed. So we start with a hydroxide ion, and that reacts with a molecule of carbon monoxide. So water will sometimes split into a hydroxide and a hydrogen ion. A passing molecule of carbon monoxide could react with the hydroxide and form carbon dioxide and another hydrogen ion. This means we now have a lot of hydrogen ions in the area, and one of those could react with a molecule of oxygen to produce hydrogen dioxide. Now this hydrogen dioxide, we will see in the next few steps, will react with nitrogen oxide to give nitrogen dioxide. After that, the nitrogen dioxide will be photolyzed to give atomic oxygen, that's one oxygen atom, and through a reaction with molecular oxygen, we will create a molecule of ozone. So let's have a look at the last few steps of that process, shall we? As we said, once we have nitrogen dioxide, it can react with sunlight to form nitrogen oxide again and an oxygen ion. This oxygen ion can then react with a molecule of normal oxygen, and that could form O3 or ozone. And you can see here that the hydroxide and nitrogen oxide are returned to the atmosphere. They are catalysts, they help the reaction, but at the end of the reaction they are unchanged. You put hydroxide in, you get hydroxide out. You put nitrogen oxide in and you get nitrogen oxide out. You can also see that step 4 is just nitrogen dioxide being broken down under sunlight. There is no other chemical involved, it just breaks the bond under the energy. So overall, the net effect of these reactions is a molecule of carbon monoxide plus 2 oxygen molecules will give you a molecule of carbon dioxide and a molecule of ozone. This is the overall balance of the reaction in the atmosphere, and as you can see, carbon monoxide is a poison, so I suppose it's good that that goes out of the atmosphere, but it takes 2 precious oxygen molecules with it. And what do we get? We get a molecule of carbon dioxide, which we know we don't want in the atmosphere, and we get ozone, which is an important gas even in the troposphere, but we don't really want to make too much of it. So with that, I think we'll leave it. Next time we're going to spend a bit of time going through some of the other air pollutants that we can find in the atmosphere and some of the ways they can cause problems for us. That's all from me for now.